When we talk about solution, we must talk about its concentration and the reaction that they can take place. Solution is just another name of homogeneous mixture. It can be created by adding solute into solvent. The solute is usually will be in a smaller amount than the solvent. The most common form of calculating concentration of solution is using molarity, where it equals to mole of the solute divided by the volume of the solution. Molarity is determined in the unit of mole per dm cube. Let's go into this example. Solutions of ammonia are sometimes used as household cleaners. How many mole of ammonia are there in 1.2 dm cube of a solution of 0.5 molarity per dm cube in ammonia solution? Since we have the volume and we have the molarity, we can just insert inside the molarity triangle to have the moles. From a balance equation and by using the molarity and volume concept, any calculation based on reaction can be achieved. Usual questions include the concentration of the reactant required for the reaction, or the volume of the product formed, or even the volume or concentration of any substance in any titration. To tackle this type of question, we will need to follow several simple steps. First, write a balance equation for the reaction. Then, calculate the mole of the substance that the data is given in the question. After that, using stoichiometry, determine the mole of the desired substance in the question, then proceed to calculate any quantity that the question asked. Let's do this example. When propane gas burns in air, carbon dioxide and water is produced. If 30 dm cube of propane at STP is burned, what mass of CO2 will be produced? First, write a balance equation. So the question gives volume of propane, which we can calculate its mole using molar volume. Since the ratio of propane to carbon dioxide is 1 to 3, then the mole of carbon dioxide is triple of that of propane. The question wants mass of carbon dioxide, so use mole concept to determine the mass of CO2 produced. Here is an example for titration. A 17.32 cm3 of 0.1237 molarity per dm cube of potassium manganate solution is needed to oxidize 25 cm3 of iron 2 sulfate solution in a titration carried out in acidic medium. What is the concentration in mole per dm cube of iron 2 solution, given the net ionic equation? So since the question already given the balance equation, we can skip the first step. So from the volume and molarity of potassium manganate given, we can calculate its mole using molarity concept. And from a balance equation, the ratio of manganate ion to iron 2 ion is 5 to 1. Then the mole of iron 2 ion must be multiplied by 5 of that of manganate ion. From the mole and volume of iron 2 sulfate, where the molarity of iron 2 sulfate solution can then be determined. Ionic equations. Ever wonder in lab when sometimes when ionic substances are added to liquid, it could form a solution, but sometimes precipitate is observed? It actually depends on the solubility of the substance in water. It all summarized in the following solubility tables. Any ionic compound containing group 1 ions, ammonium ions with nitrate, acetate, bicarbonate, chlorates, and perchlorates will be soluble in water. All halide and sulfate will be soluble except for halide and sulfate with silver, mercury, and lead, with additional of calcium, strontium, and barium for sulfates. Meanwhile, all carbonate, phosphate, chromate, sulfides, and hydroxide are insoluble except with alkaline metal, ammonium ion, and barium ion for hydroxide. Generally, the solubility of this ionic compound depends on its lattice energy. By knowing the solubility of the compounds, ionic equation can be written. Ionic equations are the equation that shows the ion that make up the substance or the ions that actually involved in the reaction. To write the Ionic equation, start with writing a balanced equation with state symbol. For any compound with an aqueous state, it can be divided into its ions. Other compounds with different state remain as it is. Then, cross out the spectator ion. These are the ions that will appear at both sides of the equation and not involved directly in the reaction. Then, write the remaining substances for the net ionic equation. Let's go into this example. Reaction of sodium hydroxide with magnesium chloride produce precipitate of magnesium hydroxide and 1 mole aqueous salt. Write the ionic equation for the reaction, include state symbols. First, write a balanced molecular equation. So NaOH and magnesium chloride will be aqueous because they are soluble, and magnesium hydroxide will be S for solid because it is a precipitate. Make sure the equation is balanced. And then any aqueous compound can be broken down into their ions. Magnesium hydroxide will remain as magnesium hydroxide because it is a precipitate. After that, we can cancel the spectator ions. So at the left hand side, we have 2 Na+, and on the right hand side, we also have 2 Na+. That means we can cancel that. Other than that, we also have chloride ion at both sides of the equation, so we can cancel that as well. So write the remaining substances. Therefore, we have 2 hydroxide ion reacting with magnesium ion to form magnesium hydroxide. This is the net ionic equation for this reaction.